Okay, this video is, should you take omega-3s? And I'll tell you right from the beginning, I don't take omega-3s. I think it's a bad idea. The video will explain why. First of all, why do women have big butts? Women have big butts and upper thighs because they store extra omega-3s up there. It's an economically efficient place, energy efficient place to store them, because our ancestors worried about starvation rather than carrying up high in the body. That's also why women got little shoulders, because their job was basically to survive and be able to carry a baby to term and be able to nurse the baby. So it's kind of like a peacock display. She's got a narrow waist, that way you know she's not pregnant. Then she's kind of got a big butt and upper thighs, so you know she's got the energy resources, she could carry a baby, and that would attract a man in the past, okay, and in the present too. Okay, she got the wider pelvis to be able to deliver baby's head. The pubic symphysis is shaped a little differently. Okay, so but anyways, it's to carry the omega-3s in a good location, energetically efficient area. Okay, why do doctors prescribe fish oils? They want to lower their triglycerides of the patients in the blood. And that sounds nice, to lower blood triglycerides, but you know what? It raises LDL cholesterol, total cholesterol, so it's not that beneficial. Has a little mild anticoagulant effect, but it's pretty next to nothing. I can tell you that because I was an imaging guided surgeon before I became a neuroradiologist primarily, and I did thousands of procedures. We never paid any attention to whether or not they're taking omega-3s. It was irrelevant. I put in tons of portacasts, nephrostomies, tons of procedures, okay, big diameter sheaths. Never once did we ever pay any attention to omega-3s. They were totally irrelevant. So the amount of anticoagulation effect is virtually insignificant. It's not cardioprotective. Studies have shown that it's not. It's not been shown to really be helpful for the brain or the eyes. You might find one study here or there, but the bulk of them, and the more you get industry funding in there, now they're going to start saying, oh, it's good. I'm not buying it. Okay. All right, so let's go to the next one. I'll show you some more stuff along those lines. What is an omega-3? First of all, when you have a fatty acid has a carboxylic acid on one side, then it has a methyl group on the other side. CH3 is a methyl group, okay? This side's polar because of all the oxygens, meaning that there's a charge asymmetry and it's soluble in an aqueous solution like water. This part is nonpolar, hydrophobic, okay, because it's just carbons and hydrogens. They have a similar electronegativity, so there's no asymmetry, significantly a charge distribution. So that's more fat, soluble in fat, not soluble in water, an aqueous solution. Okay, there's no double bonds in this fat, so this would be a saturated fat, saturated with hydrogens. That's the definition of it. Okay, now here's the different types of fats. Let me move myself out of the way a little bit here. So basically, here's sat fat. There's no double bonds. MUFA, actually this drawing's a little screwed up. There should be one double bond, a double line here. There's a PUFA. So MUFA means monounsaturated fat, meaning one double bond. PUFA means polyunsaturated. Unsaturations, meaning not saturated with hydrogen. So there's two or more double bonds in a PUFA. Okay, so here's an omega-6 fat. Counting from the methyl end, 1, 2, 3, 4, 5, 6. Then there's a double bond. There's a skip carbon, and then there's another double bond, all right? So on the skip carbon, you'll have two hydrogens. A carbon with two hydrogens is called a methylene group, and they call these a methylene bridge between the double bonds. These methylene bridges have only a weak grab onto their hydrogen, and it can be plucked off. When it's plucked off, something called lipid peroxidation can ensue. Okay, the carboxyl end over here is also called the delta end in terms of the nomenclature. Okay, so a C18 would be number of carbons, 18 carbons. 2 is a number of double bonds. And then this little omega W basically means, and then there's a number behind it, 6 and 9. So there'd be a double bond on the 6, so an omega-6 fat, and a double bond on the 9 as well there. Okay, and the C8 carbon right here, that's the methylene bridge carbon. The most important ones to know about is that basically the parent essential oils are C18-2, so this is linoleic, and it's usually just abbreviated linoleic acid, LA. And that's the only essential omega-6 fat. And then the only essential omega-3 fat is alpha-linolenic acid. Okay, so you got to say that N in there, linolenic acid, ALA. I usually call them LA and ALA. But unique point is that the C18 omega-3 has 3 double bonds. The more double bonds you have, the more vulnerable that fatty acid is to undergoing lipid peroxidation, because there's going to be 2 methylene bridges, intervening carbons, or there's only 1 methylene bridge with omega-6 fat. That's going to be relevant because the one with the extra double bonds is going to be more prone to lipid peroxidation. Rancidity, that's bad. Okay, here's one paper saying this is a paper from Dr. Greger gave a presentation, okay, and Dr. Greger pointed out that they were not cardioprotective, and he showed a whole bunch of papers on all the problems with these omega-3 fish oils. Increased risk of sudden cardiac death, often contaminated by rancidity, lipid peroxidation products. They were bad. It was a bad idea. Okay, which doctors recommend to avoid fish oils? Dr. McDougall, he says if we eat natural plant foods, we'll always, during all stages of life, get enough DHA and the other omega-3 fats. And that's in Starch Solution. It's on page 123. Okay, I went through all of Dr. McDougall's work, pretty reasonably carefully. I wanted to understand it. Okay, and he says things in a politer way than I do, but he's basically saying the same thing. Supplementing with omega-3 is a bad idea. Nathan Pritikin emphasized minimizing fats and avoiding oils. Nathan Pritikin said fat-deficient diets, they don't exist. Any naturally chosen diet will always have enough of all your fats. Okay, and what is Nathan Pritikin based that on? He did a pretty thorough review of the literature back in the 1970s. There was a study by Winitz, and Winitz was studying these chemically defined diets, and he had people on the diet for 6 months at a time, and they were fed only 0.7% of fat, so less than 1% of fat. I say that because you hear all this nonsense about essential fats. You hear all this nonsense about good fats, that people need all these good fats. Not true. Okay, they were taking less than 1% of fat, and it was only the omega-6 fat that we just talked about, linoleic acid, so C18, 18 carbons with 2 double bonds. All right, and they did very well. There were no adverse physical or psychological effects. BP and cholesterol level were decreased. They were good. Okay, so less than 1% of calories from fat. That's worth remembering. Okay, then another guy by the name of McKean in 1970 also did the same diet as Winitz, persons on less than 1% of fat, and these were children, and they also did quite well. So again, you don't even need 1% of your calories from fat. That's rather extraordinary. Okay, Dr. Esselstyn says no oil of any kind whatsoever. Let's see. All right, we'll go to the next slide here. Okay, fish oil supplements in New Zealand are highly oxidized, and they don't meet the content of N3, omega-3 PUFAs. All right, so the fish oil were mostly lower than expected in EPA and DHA, so you're not even getting what you want. There's also some question in other studies, and Jeff Nelson has reviewed it, that you're not necessarily getting these EPA and DHA even into the brain. There's a guy by the name of Brian Peskin. He's sort of a famous fatty acid researcher, and he thinks omega-3 supplements are a joke. He thinks that they're prone to lipid peroxidation and other problems, and that you're basically overdosing with omega-3s. And he also shows papers that they substitute into the cardiolipin phospholipids of your mitochondria, which normally contain omega-6s, okay, like the linoleic acid. And he says that when you put the omega-3s in there, because they substitute in because you're basically overdosing with them, he says they're damaging the mitochondria. I'm not so sure about that. I read an article about it. It didn't come flat out and say they were damaging the mitochondria, but it suggested there was an increased risk of lipid peroxidation injury in the inner mitochondrial membrane with excessive omega-3 supplementation. Okay, here's another one saying omega-3. Omega-3 was not protective against all-cause mortality, cardiac death, myocardial infarction, or stroke. Okay. Basically they're trying to use it like a pharmaceutical, and what do you get with pharmaceuticals? You get lots of side effects. Okay, here's Dr. McDougall giving a lecture, and he said, look, omega-3 supplements, they worsen type 2 diabetes. They increase your risk of becoming fat, obese. They increase your insulin resistance, so they predispose you to diabetes. You can real quick look, just search your own browser, omega-3 association with atrial fibrillation. So my point that I would make is, how would a supplement that increases your risk of obesity, increases your risk of diabetes, it increases your risk of atrial fibrillation, it increases your risk of sudden cardiac death, okay? It's an immune suppressant, thus it also increases your risk of cancer, of prostate cancer in particular. In mouse studies, it increases your risk of metastatic disease. It raises your blood cholesterol. Even though it lowers triglycerides, it raises your blood cholesterol. So how is something that have those 8 major side effects going to improve your health? Sounds to me like BS, okay? They always manipulate the study industry to try to make it look like it's doing a benefit, but you just have to use common sense, okay? What's the outer capsule made out of? Is that made out of beef, out of glycerin? How much rancidity do you have? Why do you have to put it in an opaque bottle and stick it in the fridge? Because it goes rancid super fast, all right? And then they're going to say, oh, well, we evolved, and for our brains, we need it. We need a little bit at birth. That is true. But, it's easy to get that from our plant foods. All right. Other animals don't supplement with those things. Okay. And we're not natural to eat fish. Theoretically, if humans did evolve from equatorial Africa, a hot climate, that's not where they need omega-3s. They'd actually be a liability there, having a lot of them. That's more of a thing for cold ocean water fish where it's near freezing because they have a different freezing point. Okay, what I'm trying to say is that evolution argument is bogus. All right, prostate cancer risk. They increase the risk of prostate cancer. This guy's a pretty prominent researcher, Brasky, and there were several different studies where they increase the risk of prostate cancer. And anything that increases the risk of prostate cancer usually increases the risk of breast cancer, but I haven't seen the paper to show that yet, but I will bet that that's the case. Okay, therapeutic potential, omega-3 and autoimmune disease. Okay, they suppress immune systems. Some people say you got to get all these omega-3s to treat autoimmune disease. And what I would say is, why not first look for the cause? Because again, you're using it like a pharmaceutical rather than what the low-fat vegans like to do is we like to reduce our risk of something. So what I would do with an autoimmune disease, number one, focus on preventing leaky gut. Eat more dietary fiber. Avoid all the things that increase your risk of leaky gut, like fluoride in your water, chlorine in your water. You can easily remove that, reverse osmosis. What are the other things? If you're taking antibiotics, emulsifiers, processed food, if you're eating high-fat diets, if you're eating oils, if you're taking NSAID medications, there's a lot of things that will cause leaky gut. You want to avoid all those things. What else? If you're inhaling volatile organic chemicals, all those things that transform rapidly from liquid to solid, like paint, glues, adhesive, time at the nail salon, inhaling printer's ink, all of those things, trichloroethylene, will have an effect that they can sometimes damage tissue, make damps, and cause autoimmune disease. Fluoride can also cause autoimmune disease for those reasons. Glyphosate can substitute out for glycines and damage tissues and cause autoimmune disease. So that's a chemical mechanism of autoimmune disease. So what I'm saying is I would fix all those problems. If you still have an autoimmune disease after having fixed all those things, then I would consider immunosuppressing with these omega-3s. But I would do that only as a last resort. Well, that's actually not the last resort. The last resort would be those chemical drugs that are immunosuppressants, like methotrexate or something. I would try to fix it with this first. But what I'm trying to say is I wouldn't go to this first until I dealt with all the leaky gut type stuff and all the chemical causes of autoimmune disease. Okay, omega-3 fish consumption and risk of type 2 diabetes. Another paper showing increased risk of type 2 diabetes with omega-3 fishes. So to me, that's like crazy nonsense. How is something that increases your risk of diabetes going to make you healthy? It makes you fat. It makes you diabetic. Raises your total cholesterol. Come on. Causes increased insulin resistance. Increased weight gain. Okay, here's 2 papers on that. Oh, this is just other problems with eating fish. All the the mercury, the PCBs, the other toxins, and I don't know how much of those get into the omega-3s. We talked about how, with all these double bonds. Look at this, EPA, eicosapentaenoic acid, 5 double bonds. So you're going to be super predisposed to lipid peroxidation. DHA, 6 double bonds. That's going to be much, much more than those, ALA was, which you get from the plants. Sounds bogus. Okay, we know it's not cardioprotective, and I don't think it's neuroprotective either. I know there's some recent studies with industry funding, helping to fund them, that, in my opinion, make it look better than it is. Okay, here's other previous studies showing that it was not neuroprotective for Alzheimer's, because I know there's some people talking about it being neuroprotective for Alzheimer's, but, you've heard me talk about Alzheimer's too. Alzheimer's is kind of a big joke. It doesn't even really exist. It's a fake disease. Okay, this is the prostate cancer additional references. Oh, and here it is showing that it increases the risk of colon cancer metastases in rats. Another paper here that it also increases colon cancer risk in rats. It's an immunosuppressant. You would expect it to increase cancer risk. Okay, can humans get enough 3? You get plenty from plants. Vegans are not deficient in omega-3s. All right, here it is showing the amounts you get plenty from plants. And I told you the other things. We talked about the research study. Here's just more research study. So anyways, I hope that's helpful. Bottom line, I don't think omega-3 supplements are a good idea for any reason.